This is the tutorial on how to load data into SeisTool. SeisTool is TraceSeis' rock physics tool. It uses effective media relationships to model P-wave velocity, S-wave velocity, and density logs and seismic data for different reservoir conditions. That is, we will be able to modify porosity, lithology, and pore fluids, and reconstruct P-wave velocity, S-wave velocity, and density logs as if they had been acquired under the modified condition. The inputs to SeisTool are the P-wave velocity, S-wave velocity, and density logs, a petrophysical evaluation, which includes the volume fractions of the rock's constituents, and a target flag. Data is input in LAS format, and there are two possible ways in which the petrophysical evaluation can be input. It can be either binary or multimineral, and we'll make some comments about each one of these in the next couple of slides. The multimineral evaluation is constituted of two or more minerals and two fluids. The fluids are commonly the hydrocarbons and the brine. The main characteristic of this petrophysical evaluation is that the addition of all the constituents equals 1 at every depth sample. That is, if I come in here and if I take the volume of brine plus the volume of shale and the volume of sand, these are going to add up to 1. This is in contrast to the binary petrophysical evaluation, which is usually provided as V shale, water saturation, and porosity. In this V shale is the fraction of the solid phase, that is shale, and its values can go from 0 to 1. Similarly, SW or water saturation is the fraction of the fluid phase, that is brine, and its values can also go from 0 to 1. And finally, the porosity is the fraction of the rock that is void, and this is the same as for the multimineral case. So if we come in here and we take V shale plus porosity plus water saturation, the result will not be necessarily equal to 1. It is very simple to convert from binary to multimineral using these relationships, and this is what SeisTool does when the data is loaded. Let's now load some data into SeisTool. Let's start by loading an LAS file from a binary petrophysical evaluation. Here's where we're going to select whether this is binary or multimineral. The data is read in LAS format. When the LAS file is selected, the mnemonics and units table is populated. Here, this is the name of the file with which the well is going to be saved. Let's call it TUT02. And this is the name of the well that is going to be annotated in all the plots that we create. Let's call it tutorial 02. We can now assign different mnemonics to the properties, depth and depth, P-wave velocity. It can be read in as a velocity or as a sonic. S-wave velocity as well could be read in as a velocity or a shear wave sonic. Density log, porosity, target. Let's change the name here to pay, water saturation. Here we're going to read twice the water saturation log, and that is just so that we can assign different names to the hydrocarbon phase and to the non-hydrocarbon phase. Let's assign the name of gas to the hydrocarbon phase, leave brine the same, and the same with V shale. We assign the first V shale, the second V shale, and let's change the name of the sand to S for sandstone. We can now read in the well and display it. Here in the left we have the binary petrophysical evaluation that we just read in, and in the right is the conversion or the computation of the multimineral petrophysical evaluation from the binary, plotted from 0 to 1 in a cumulative volume plot. Here the name of the well is tutorial 02, just the way that we assigned it down in here. We can also color fill the petrophysics. When we push this button, we get a a warning or a message saying that this may take a while if we decide to do it for very large wells. This is not a large well, so we're going to plot it. We say that we are aware, and then do data load to see the logs again. And here we have now the same multimineral petrophysical evaluation that we were seeing before, but now with the petrophysics filled with color. Let's now save the well. It's been saved, and if we check in here, it should now appear here. This is TUT02. Let's now load a multi-mineral well. Here it asks for the number of fluids and the number of minerals. The best way to know this is by reading the LAS file. This is a synthetic multi-mineral evaluation that I made because I do not have real data that I can show. Do open, and we have here the mnemonics in the LAS file header. We are going to do a multi-mineral. We now see that we're going to have 1, 2, 3, 4, 5, 6, 7 minerals. So we're writing here 7. And we're going to do 2 fluids. Right now the program only takes 2 fluids, and we can start assigning mnemonics to the different properties. So here's depth, and assign P-wave velocity, S-wave velocity, density, porosity. Let's change the name that is going to be displayed to pay as well. Here we have water saturation, so we assign it twice. We could also have had a volume fractions of fluid 1 and fluid 2 and put these the different names. When the program sees that it's the same mnemonic, it's going to assume that it's water saturation, and it's going to do the computation internally to obtain the volume fractions of fluid 1 and fluid 2. Let's change the name here to gas, brine, and let's start assigning the minerals. Let's start with quartz, feldspar. Let's do now montmorillonite, illite, smectite, silt, and finally carbonate. Now let's change the names. Let's do this: quartz, feldspar, montmorillonite, illite, smectite, silt, and finally carbonate. We can now look at the data. This is the QC for the multimineral petrophysical evaluation. In track 1, it's adding the volume fraction of the fluids. This should be equal to the porosity. So when we subtract the fluids minus the porosity, we should get a value of 0. This is very close to 0, as you can see. The second track is going to add the volume fractions of the solids and subtract this from the solidity, or 1 minus porosity. This should be 0 as well, and it's very close to 0. In the third track, we are adding solids and fluids, and they should add up to 1, which is the case for this synthetic well. And the last track is the petrophysical evaluation. In this case, the petrophysics haven't been color filled. Let's now try to do the color fill in the petrophysics. Again, we get the message. This is a large well, so it's going to take about 40 seconds. We're going to plot it anyway. I click yes just to say that I'm aware, and then load the data or display the data. And right now the display is being generated. It's doing color petrophysics. It's take a while there. What I usually do is that I do everything without doing the color fill in the petrophysics, and then when I am ready to create a report or a presentation, I do the color fill in the petrophysics. Many of the wells, I'd say most of them are small enough so that you can always display the petrophysics with color fill. For now, I'm going to stop the presentation to pause the presentation a little bit while this completes. It has plotted now. It took 38 seconds to generate. Here we can plot as well the units in metric or in English. This is in metric. Let's look at the display in metric. This is in meters. If we want to look at this in English, we need to select English, save, and then load the data. And here we see it in English. The last thing that we can do is to save the logs and or to save the well. Let's give this a name of TUT02-multimineral, and the annotation for this well, let's make it tutorial 02mm. mm for multimineral, and we can now save the well. We save it and we see that it should be here. Yeah, TUT02 multimineral and the previous one, which is the binary. So we're now ready to plot or to make the analysis on the data. We can select any of the other modules. Let's do it with the well log analysis at log resolution. And here we select the well. Let's do the tutorial 02, which is the binary. We can do the log plot or the scatter plot or anything else that we would like to do. This concludes the tutorial on how to data SeisTool. Thank you very much.